Growth. That means something is not disappeared. Starting from the smallest thing, the charge conservation law, until its interaction becomes a momentum conservation law, and the biggest of the whole universe is the energy conservation law. From bright energy to the dark energy. And you know that our universe consists of only 4.9% of the bright energy. Bright energy means we have only the radiation carried out or released by the visible things. And the dark energy is like, for example, you see the gravitational energy is very huge, propagates in the whole universe. It's one of the sum of dark energy. No radiation. And in 2013, the scientists from reporting in Nature magazine, it's about 95.1% of the whole universe. Okay, so this all one system, but there's many. Not just like I can do. My hand can fly away. It's only in one time, right? So it's a multitasking system. Also, we can apply it into science. Okay, here how our dean is observe our work on campus. He already put many cameras inside our campus, so he can monitor. So one day there is one student wallet disappeared. So he says, if somebody do not try to put it back to the owner, I can show the video recorded by my room. So instantly he returned it. Okay, so this is the meeting just before we come here. This is our staff here. We just have a meeting before we come here. So and also here we have a dinner in dinner or lunch. In the shop. Okay, so how we have to. Okay, anyway, this is the idea why we try to apply the nano science or nanotechnology system into our technology. First, if we see the color shows the size. For example, this is a green illuminated particle, nanoparticle, and the smaller size than this orange or will be bigger, it becomes red. Just like I showed you have a many beautiful mark outside, red color, pink color, yellow color, so it will be related. In the biology, it's a different gene, a different color. But in physics, it may have a different size of gene. You can do some more detailed investigation. Because as a physicist, we can identify something from the color. It's related to the size. Just like I have a gold. If your gold is a pink color, maybe dark red, that means the inside is not normal gold, but it's already a nanoparticle, gold nanoparticle, because the color is same. It's due to the size. The total of nano size is about 100 to 1,000 atoms make a one nanoparticle. Okay, so one nanoparticle is a different color with a 2 nanometer particle, different size with another 20 nanometer particle. Okay, so different size of nanoparticle has a different character. Okay, so this is interesting of the physical side of this kind of nanotechnology. So I built a nanotechnology research center at University, starting from 2 scientists at Patimonia University. It was the first one in the whole eastern part of Indonesia. So that's why scientists is the most important thing. If you have a scientist, you have the future. You have many facilities, but there's no scientist there. How you can build science, right? So, and the younger scientist now, he is pursuing PhD in one of the Japan University in Kyushu. I took a nano device because based on my recommendation, you have to take the nano device to complement me as a nano scientist. So he was successful, and he got the best scholarship of Indonesian government because everything in this scholarship higher than the Monbuzo scholarship provided by the Japan government. But it is very selective. So from the eastern part, only him from Maluku was accepted the scholarship. Okay, and all right. So here, what we are doing now in our Faculty of Mathematics and Neuroscience, especially in the department. So Here we have our nanotechnology center. We work using very simple thing from supermarket tool. Okay, but our brain is not like supermarket tool, right? So, for example, you must have a very strong background also in theoretical physics. We see something we have to do like I saw you have a very strong simulation technique, modeling and so on in your computer system. Also this morning I saw from one of the Indonesian last years presented downstairs. So it's like wind and water, and then our life and technology. We can do our thinking now using the handphone. From this handphone, I can just do presentation, and I can control from the handphone. Okay, and if the student looks very quiet, okay, let's have a cheers. We can have a cheers. So I did it in my study in Mattimura University. So it is very different from your style here in Germany. So it may have an idea to change your lifestyle, not just like a rigid style, but you have to enjoy it, right? Okay, this is from 1,740 islands. We have 27 important areas from north part to the south part. I remember this when I was 11 years old, and now I never forget about it. That means it's already a part of my life. I don't need to remember, but I already become a part. That's like your German language. You never remember, but you already know how to talk in German, right? So it's like, for example, like this. Morotai Hamera, Tanate di Dori Bachan, Obi Mawar, Sana, Bursha, Hamera, Subraman, until 27 islands, no need to be remembered. It's already part of your life, just like you master your German language, right? I master my Indonesian language. So just something like that. So from this, we have a variety of the Austrian countries. A lot of physics and technology can be applied to do some research. This is our small group. We started, we call it the Laboratory of Computational Oceanography and Weather. Starting from the two of us, and this is our students. 5 of them already graduated, and the first undergraduate student who get their degree with already have an international publication. So it's very rare in Indonesia, but from a small island we can make a difference. So it depends how we work. This is our Mattimura University airport. So we have a lot of beautiful sea vegetable and sea animals and so on. Especially we have a banana sea with a lot of very rare creatures inside. It's about 7,000 deep sea. Okay, this is one of our work. We study the computational oceanography and weather, the interaction between ocean and the wind inside in a different season. For example, this is a northwest monsoon and a southwest monsoon, and we can identify the deep of the ocean, what happened inside it versus the temperature in each given deep. The data of this you can get from many type of the satellite. Some of the provider like NOAA and so on is free. We can take the data and we can analyze in the certain area. So this is the banana sea. This is our island. Our island located just below the biggest island, which is Serap Island, the Bulu Island. So only in this area they have about 8,000 islands. Yes, 8,000 islands. Many small islands here located in this one part of the province. So over there, the giant turtle on earth is always go there to take the food. Have you ever heard about the leatherback turtle? It's as big as me, and the structure of the body is a little bit different. It's like a 5, not like a square. So many unique creatures there. Okay, this is we work with the international team. They trust us. This actually appeared in this Science magazine last month. the billionaire donate this kind of medicine can die, and the data can be broadcast to the satellite and be controlled from the internet from using your handphone, and they can collect the data of the salinity versus the temperature. So this device, we get two devices. One of them will be released in the bandasi in deep sea, so it can die, controlled by the satellite using your handphone or your computer connected to the internet. So it goes collaboration with the IPB, is one of the best university in Indonesia, in the west of Java, Institute Pertanian Bogor. It's one of the 5 best institutes in Indonesia. So initially the scientists come to us and they bring these two devices from France, and now we are starting collecting the data. Okay, this is our server is just small. We can mobile system because we have many islands. We can carry out our server to whatever we go, just using the boat or ship or anything. So, this is the data. And we are using a small smart tool to do simple multitask experiment between optic, electronic, and also another temperature sensor to understand. Okay, this is the first of my method to make all type of wasting to become vibrant. This is the first experiment I did by myself before I teach my students. Since then, I have supervised about 34 students who are working in different type of fiber, in many type of waste. Different student has a different type of certain waste. And this is our island. You can see there are two high peak in the island. One here, one there, and one here. So, and here we have a maritime and marine science center of excellence. And now it's headed by our scientists who get Ph.D. from Germany, Dr. Gino. So I was there as a one-room part of the research center to do this kind of computational oceanography and weather to help them. So we work a lot of things. And okay, this is some of our, and the most expensive equipment we have is this, is the FTIR spectroscopy. Last few days we went to Humboldt University, and we entered the image container library. They sell the FTIR handbooks as thick as I bought two, because one is only €5. Okay, so it's very important to check many types of chemicals, FTIR spectroscopy. So this is the only expensive equipment we have. The others we just use our brain for any mobile system. Okay, as a result of our hard work for many years, so now I'm standing here as the 20 best scientists in the whole Indonesia. We have about 250,000 lecturers from the private and government university. So we, but in my university, is the one scientist. So he is, and many scientists above here, they are mostly in the 5 top best universities in the whole Indonesia. Our university is maybe ranked number 45 in the whole Indonesia from many thousand universities. Here is how we change fiber by using fire and without fire. If you face storm, you don't need to use the fire. Okay? You just change the structure to become a fire. If you face garbage like from leaf, from branch, from you can just burn it. You can get the new structure full of the carbon. Right? If you're putting something, there's carbon there. Carbon nanotube, I did many work into carbon nanomaterial. Carbon nanotube is a polyurethane, carbon 60 polyurethane, and carbon polyurethane modified with many types of derivatives. And so I knew, and the carbon become a certain thing, like diamond become very strong. The strongest, the strongest carbon structure is the diamond, right? But this material can make a very strong covenant tooth, about 1,000 times stronger than steel, mechanically. Okay, I still have 2 minutes. Okay, this is one of our integrated work. This is our fiber. We try to make a simple device. We measure when it vibrates. How about the speed of velocity? How big when there is influence from the certain temperature from 300 degrees Celsius to 70 degrees Celsius. So, and we measure the speed of sound propagating to our pipe, for example. So we publish in this journal. And this is one of my first theoretical PhD students. So she did present in our third international conference at the Faculty of Mathematics and Natural Sciences at Padua University. She and also published in this conference proceeding. And this is the man who did this. Before I came here, I go to the basic bank and I found him. Yes, suddenly he became already one of the good employees. So I changed the euro to come here. I found him suddenly. Okay, this guy, the young scientist, is already in Japan. Suppose this is the second year for a Ph.D. in nanodevice. And this is our work to analyze the water contamination due to the calcium carbonate, because many people stay near the beach, many islands, so the calcium carbonate already become mixed with water, so many very high calcium carbonate. So we study the physics, the aggregation process, why it changes in the given temperature, and we try to find out the unique thing. So we use our simple sensor connected to a small device, to the computer, so we can check exactly time versus temperature, and we can find certain character of the system. Okay, and this is just an idea that something new is our motivation to do research. If there's no novelty, there's no point in research. So it's already happened a long time ago. In the last December, John, he just passed away about 90 after birth. This is our university. This is the largest. This is a place for the graduation ceremony for the commencement day. So this is about 1,500 students can have a graduation ceremony here. So we are going to do this kind of first international conference on frontier physics and multi-testing application, and I will be the leader and some invited speaker of analysis. And this is from one top leader from ICE, one of the best institutions of industrial science in Japan. He will come also and do sign the LOI in front of this conference with our team. Okay, this is kind of, we do image processing with this kind of medical data from the X-ray photo, and we can check this guy has a tumor, what kind of tumor, based on the image. We do a fast forward transform imaging, and so this is one of our best students. We use with the GPA 3.8, only 3.6 years in our university. We have a 8-semester study, so at least 4 years, but this guy is great. He will just finish last earlier, and great job. Okay, this we also do the nanomedicine. Currently, I do collaboration with the North Park scientists. So we try to do physical system, and we do the quantum system to understand what happened inside. We have lost because of hammer, because the antioxidant content discovered by the North Park scientists using the indigenous wheat. They call the Halmahera wheat, the second important area on the North Park. It has the highest content of the antioxidant in the world, about 6.64 nanogram per milliliter. So he asked me to do how to explain this. Okay, so this is the result. We haven't published this one, so I sent it to you. So there are many things we can discuss. Okay, so okay, this is for example our Japanese oceanographic weather research data from 2007 to 2014 in the different layer of the ocean, top layer, mixed layer, and then the thermocline layer, and then below thermocline layer. So this from 0 meter to up to 318 meter below the ocean. We can study anything in terms of the deep and the temperature, the salinity. Okay. This is our laboratory. We are now doing the electricity changing from chemical to electricity. Okay, because time is up, so maybe we can discuss later. I also have many art things. I did painting very. Okay, this is a conclusion. So mainly the achievement of the molecular science and technology is from Patimura University. So we are here as probably the best scientists from our university for you. So we hope that we can do cooperation in the future. We turn to Professor Diego.
Okay.
Thank you.
Okay, thank you very much.